All right, so today we're gonna, this is day 5, so we're gonna kind of switch gears a little bit. We're gonna analyze data, which means we're gonna collect data and we're gonna try to summarize it using different measurements. So our learning target, I can analyze data by calculating measures of central tendency. So that's where you basically try to find, where's the middle at the data, kind of give you an idea of what's going on. So like an average, if you want to know how good a basketball player is, well, how many points do they score? Or maybe you care about rebounds. So on average, what's kind of the normal number of rebounds they get. And then I can also draw and interpret a box and whisker plot, which it's a way of displaying data. It's easier to see the data. You might see things that you wouldn't recognize just by looking at a list of numbers. Kind of visually gives you a picture of the data. So often in statistics, we want to use a single number to summarize a set of data. And obviously there's different ways of doing it. There are different ways of measuring, but it depends what you're looking for. But one way is to find the measure of central tendency. So measure of central tendency, or the middle of the data set. The most common summaries, the most common way to summarize it is finding the mean, or finding the median, or finding the mode. So you did a lot of this. This used to be an ISEP standard when you're in middle school. So the mean, which is another name for average, just another name for average. You add up all the numbers, and you divide it by the number of numbers. Okay, so on this one, if I have this data set, I'm going to use the data set 1, 2, 3, 3, 4, 5, 5, and 9. I'm going to add up those numbers. So I'm going to add those up, and I'm going to divide by 1, 2, 3, 4, 5, 6, 7, 8. There's 8 numbers there. If I add those up, that's 32 divided by 8. So 4 is the average. So the middle of the data is about a 4. Another way of measuring it is median. Okay, and the median means the middle number. If you have an even number of numbers, that means there is no middle number, so you'll take the average of the middle two. That's what that's saying. But you got to order them from least to greatest first, which I've done for you. Put them from least to greatest. And the middle number would be, if I split the data right there, there'd be 4, 4, and 4. So the middle two numbers are 3 and 4. So I'll take 3 plus 4 and divide by 2, which is 3.5. So notice, slightly different, but not a lot different. Not a huge difference. Now the mode is not necessarily a central tendency. It's more like what occurs most often. Like this one's literally the most frequently occurring value. And it is possible to have more than one. So there can be more than one mode. So when a data set has 2 modes, it's called bimodal. It can be more than that. There can be 5 numbers that are all occurring twice. Well, then there's 5 modes to it, and then it's not really that helpful to use. So there's a certain situation where it's helpful. In no mode's a possibility too. If all the numbers are different, then there's no mode. They all have the same frequency, so it wouldn't matter. But in this case, 3 happens twice and 5 happens twice. So the modes, this would be bimodal, and it'd be 3 and 5. 3 comma 5. So there's 3 different ways of measuring the central tendency about, on a normal, if this was a number of points you scored in 8 games, that means most of the time you score 4, or about 3.5, or 3 and 5. So there's 3 different ways of doing it. Now, why do we have different ways of doing it? Well, if you notice, like out of these numbers, they're all pretty close together except for that 9. That 9's a little bit, it's not necessarily what we call an outlier, but it's further away from the data than the rest. So when you have a number that's further away from the data, the mean can be drastically changed, whereas the median won't be as affected. If I covered that number up and recalculated, they'd be a lot closer together. But with that bigger number, the mean got pulled more than the median did. And by the mode, it's kind of its own thing. So let's talk more about outliers here. So now we do have an informal definition over here. An informal definition of an outlier is when, if you look at the differences here, so order least to greatest, these two are 3 apart, none apart, 6, 0, 8, 25 apart. So if you just looked at this data, you'd say, oh man, that 98's way out there. Now, there is an official definition of an outlier, but that's kind of the informal definition. It's just a number that's way out there. And we want to look at how that number way out there affects the data. Okay, so I'm not going to go through all the steps here. I want you to find the mean, median, mode with the outlier, which if you're looking at this, what would you think the outlier would be? If I just look at the data here, it looks like 54 is the outlier. So this one is with 54 included. This one, throw 54 out and recalculate everything. Okay, so I'm going to pause. I'm going to calculate it, and then I want you to calculate it yourself. Like, see what numbers you get with and without that outlier, without 54. Okay, so now we've got, which first off, I put them in order from least to greatest. That's going to help me find the median. But for the mean, if I add them up, I get 228 divided by 10. But if I throw 54 out, now I'm only dividing by 9. And you could just say 228 minus 54, and it's a little bit faster and get 174. So 174 divided by 9. So notice, with an outlier, my average is 22.8. Without it, it dropped to 19.3. It dropped quite a bit. The median, though, only dropped half of the value. And the mode didn't change at all. So the mean, we say that the mean is susceptible to outliers, the median's a little more resistant. So if you're looking at data that has some outliers, the mean may not be the best way to measure it. So, in your grade, if you have one or two really good or really bad tests or really bad assessments versus the rest, technically mean is probably not the best way to look at what you do most of the time. Median would be better. That's not how we calculate grades, but nobody asked the math people how to do that when they decided to do grades. So, but median and mode are a little more resistant to those kind of things, to the outliers. Okay, so another way to summarize data is by calculating how spread out it is. Well, here we looked for center. Here we're going to look for how spread out it is. So how consistent is the data? So we call that a measure of spread or measure of dispersion. Spread or dispersion. I kind of interchange the words. Some measures of spread include range and IQR. So range is pretty easy to find. Your range is going to be your biggest number minus your smallest number. So once a data has been ordered from least to greatest, the range is the difference between the largest value and the smallest value. The IQR is a little different. Okay, the IQR is the difference between Q3, which we haven't talked about yet, and Q1. Now, Q3 and Q1, they are basically the medians of the first half and the second half. So in this data, we order it from least to greatest. If we want to find the median, count them off. The middle two numbers are right here. So the median is 76. Now, without including, we want to take away the top half and the median. So if I take away the top half, including the median, that means I'm going to cover this up. 74 stays, because 74 wasn't the median. I used it to find the median, but it wasn't part of it. So now I've got 1, 2, 3, 4, 5, 6. Well, the middle two numbers there would be 64 and 68. That means Q1 would be the average of those two, 66. So it's the median of the first half, the lower half. Median of the median, basically, median of the first half. And then if I want to find Q3, I got to cut off the bottom half of the data, including the median. So if there's an odd number of numbers, you got to get rid of the median. So here's the top half. So 1, 2, 3, 6 of them here. Middle number is 84. Well, it is 84 because the average is 84 and 84. So the Q1 is 66. The median, which you could also call Q2, it's not very often it's not called that, but you technically could call it Q2, is 76, and this is 84. What that's doing is splitting it into quarters. So the lower 25% of the data is between 62 and 64. The middle, or I should say the next 25, so the 25% to 50% is between 66 and 76. From 50% to 75% is between 76 and 84, and then the top 25% is 84 and above. So it kind of gives you an idea of where the data is. So let's find the range and the IQR here. So the range, and I've already ordered it from least to greatest for you. I'll try to save you some time. 87 minus 69. That's 18. Would range be susceptible to outliers? Yes. If I throw one big outlier into that range could explode. So range is not always a good measure of of spread, because if you have one outlier, it makes it look a lot worse than what it really is. The IQR might be better. Now the IQR is I take Q3 minus Q1. So notice what percent of the data is between Q3 and Q1. So 25% was between Q1 and the median, 25% between the median and Q3. That means the middle 50%. So IQR is literally the middle 50%. So that's almost a measure of dispersion and a measure of central tendency. It kind of tells you most likely what's going to happen. There's a 50% chance going to be between these two numbers. So for this, my IQR, now I got to find my median first. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if I go 1, 2, 3, 4, 5, 6, put a line here. So there I split it in half. That means the median would be 80. Not needed to find the IQR, but it's good to know. Now I'm going to take the bottom half of the data, so do not include that 80. So I got 1, 2, 3, 4, 5, 6. That means these two numbers right here. So Q1 would equal 73.5. So it's the middle of 72 and 75. Now to find Q3, again, there's 6 numbers in the top half of the data. So here's the middle. I'm going to write it above. So Q3 would be 85.5. So my IQR is going to be 85.5 minus 73.5, which is 12. So that's my IQR is 12. Okay. Eventually we use IQR to give a hard definition of an outlier. Because like up here, this was informal. So this was 25 units away. But what if it's only 24? Would that still be an outlier? What if it's only 20, 19, 18 cents? There's really no black and white. There's kind of a gray area. The formal definition is it has a definite yes or no. Everything is or is not an outlier. So it's going to be a definite yes or no. So let's flip this over. And what we're going to do is we're going to use, we call that, by the way, the Qs and the median. So Q1, median, and Q3, along with the min and max, we call that a 5-number summary. Okay, so this is the same thing as a 5-number summary. And we use that to make what's called a box and whisker plot. Now, the box and whisker plot, we got the minimum, quartiles, and the maximum written down here. What it does is there's the bottom fourth of the data, the second fourth, the third fourth, and the fourth fourth. Kind of shows you just how the data is spread out. Notice, and this is like the number one missed thing about box and whisker plots, or box plots, they're also called. You can just call box plots. Is we put them on an axis that's not evenly spaced. Every space is worth the same. If you don't make the spaces worth the same, it's not going to show anything. It's really not helpful at all. Okay, so let's click on this one. Let's look at the data. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Hey, we got an odd number here. So that means there's going to be 5 numbers. There's 11 total, split it in half, and there's 1 in the middle. So there's going to be 1, 2, 3, 4, 5, 1 in the middle, 1, 2, 3, 4, 5. There is the median, which can also be called the Q2. Now to find Q1, again, cover up the median too, the top half of the data and the median. So I'm going to cover up the median. I got 1, 2, 3, 4, 5. That means this is Q1. And covering up the median in the bottom half of the data, I got 1, 2, 3. There's the median of the top half, so that's Q3. And then this is the min. This is the max. So I want to make, again, that's the 5-number summary, right there, 5-number summary. I want to make a box and whisker plot. So first I need to draw a line, and I want to scale it evenly. Now this, I needed to go from, I don't know, like 10 to 35 roughly. So I'm going to start it at 10, and I might go like every 5. So this would be 15, 20, 25, 30, 35. Okay? So now see how every space is worth 5. Now I'm going to plot the points. Okay, so I'm going to plot the points. So 11 would be about right here. That's the whisker. The box itself starts at about 12, so that would be about right here, about 12. And then the box keeps going. There's a line at the median, so median's 15. That's the middle of the box. The box is going to end at Q3, which is at 19, which is about right there. make your box. Here's one whisker. And then 30 is over here. There's the other whisker. Okay? So how's the data spread out? 1/4 of the data is in that small gap. That's packed pretty tightly together. Here's the top fourth of the data. It's very spread out. So this has a widespread. This is really tightly packed together. Okay, and we actually call that like a skewness. It's skewed one way. The data, you get a few high numbers here, but most of them are packed in pretty tight. Half the data is between my fingers. Another half the data is between there, and another half is there. So like that's a big gap, small gap, small gap. So it's kind of as it gets bigger, the data starts spreading out. Okay. Now, is 30 an outlier? So let's give this a hard definition. Is 30 an outlier? Is that too far away from the data? So difference of 1, difference of 0, 1, 1, 2, 1, 1, 11. Is that too big of a gap? Well, what we do is we actually use the IQR. So here, we found Q1 to equal 12 and Q3 to equal 19. That's what we found above. IQR would be 19 minus 12, which is 7. How we find this then? So this is IQR of 7. I'm going to take IQR times 1.5. So I'm going to take 1.5 times the IQR times 17, and this equals 10.5. Now I'm allowed to go 10.5 above Q3 and 10.5 below Q1 and still be considered a normal data point, not an outlier. So if I took Q1 minus this amount, and this right here is 10.5. So Q1 was 12 minus 10.5. That's going to be 1.5. That's my lower bound. Okay, no data was below 1.5, so no low outliers. Now I'm going to take Q3 plus that number. Again, this number right here is 10.5, the one I found. Q3 is 19 plus 10.5. Okay, so that would be 29.5. So, is 30 an outlier? Well, this is an upper bound. Anything above 29.5 would be considered an outlier. So any value less than 1.5 or larger than 29.5 is an outlier. Yes, 30 is an outlier. It's too big. Okay? Now how we would actually graph that with our box and whisker plot, we want to note that outliers exist. This 29.5 is where the whisker should stop. So the whisker should stop right here. There's a little gap, and then we put a star or a dot. Whoops. Thank goodness, I forgot to draw a star. So this stops short of it. There's a little gap there. We put a star or a dot or an open circle. They use different. It all depends what you're using. But it's just some way to note it. There's no like universal symbol for it. Okay. So again, that just kind of shows it. Now, another one of our standards is, can we use box and whisker plots to analyze the data? Okay, so as I'm looking at this, these are the box and whisker plots that show the 35 best qualifying distances for the shot put for men and women during the 2004 Olympics. Compare them. Okay, describe any conclusions that you can draw. So write down anything you see about it. And generally, we look for what's called the center, the shape, and the spread. So center, shape, and spread. Now, shape we don't get into as much in Algebra 2, so I want to really focus on center and spread. So where's the center? Like, who generally throws the shot put further? Well, in this one, men generally throw it further. The shortest throw by a man was shorter than the longest throw by a woman. So it's not that every man threw it further than every woman, but in general, this graph is further down the line. So in general, men, so typically a man will throw further. Okay. Now look at the spread. Okay, so which one spread out more? Which one's more consistent? So if we were looking at this, the men's shot put is more consistent because there's less variation. The women's, there's a couple of really good women here that beat the average man. The median is kind of the middle, and this furthest throw actually beat the normal man's throw. But in general, it's pretty spread out. It's pretty sporadic, whereas the men's is a little more consistent. So we say center, look for where's the center at, and then spread is how far spread out it is. Okay. So now the shape itself would be like if it's lean, if it's stretched out. this is fairly symmetrical, that's fairly symmetrical. We're not going to get into that a lot in Algebra 2. That'd be a statistics if you took stats and probability or AP stats. Like this one is really stretched out this way. So you'd say that it's skewed this way because it's kind of spread out, whereas a lot of the data is packed in tight over here. That's what shape is. Don't worry about that so much. We're worried about center and spread.